So the sum from I equals 1 to n of 1 is just going to be 1 plus 1 plus 1 plus 1 n times. So the result is just going to be n. The next summation that we need to know is the sum from I equals 1 to n of r. That's an r. So that's going to be 1 plus 2 plus 3 plus 4 all the way up to n. And then we can write this as n plus 1 over 2. Okay, so that's a closed form expression for that sum. Okay, and then the next one we need to know is the sum from I equals 1 to n of r squared. Okay, so that's 1 plus 4 plus 9 and so on. We can write this as n plus 1 to n plus 1 all over 6. And then the last one we need to know is the sum from I equals 1 to n of I cubed. And this one's pretty easy to remember because we just look at the above formula for the sum of r, and then we square it. So it's going to be n plus 1 over 2, and then all of that squared. Okay, so not too bad to remember, just 4 of these, and then you should be able to do the Riemann integrals. Okay, so I'm just going to leave this here so that we can refer to it later on. But let's take a look at our first example. Okay, so this is example number 1. So we need to find the area under f of x is equal to x minus x squared on the interval 0, 1. Okay, so we don't need to draw anything. We can just imagine this parabola shape, and then we want to find the area underneath that shape between 0 and 1. Okay, so remember the steps from last time. We start off by finding delta x. That's going to be b minus a over n. In other words, the upper bound minus the lower bound divided by n. So that's going to be 1 minus 0 divided by n. So that's 1 over n. Okay, that's easy to do. The next thing that we need to find is xr. Remember, this is a plus I delta x. And we already found delta x, delta x in the previous line. A is 0, so it's just going to be 0 plus I over n. So that's just I over n. Okay, so that's xr. And then the last thing that we need to find is f of xr. So remember, f of x is x minus x squared. So this is going to be I over n minus I over n squared. So xr minus xr squared. And then I just substituted what xr is. Okay, but we can do the square over here. So this is going to be I over n minus r squared over n squared. Okay, so these are the 3 important things that we need to find before we do the calculation. So need to find before calculation. Okay, so it's good to find all of these things now. And then when we do the calculation, we can just substitute everything in. Okay, so let's do the proper calculation now. So we want to find the area. So the area is equal to the limit as n goes to infinity of the sum from I equals 1 to n f of xr delta x. Okay, so you see that's why we found these things before over here. So we do all the stuff before, and then we can just substitute into here. So it makes things a bit easier for us. Okay, so let's just substitute what we know and then do the calculations. So this will be the limit as n goes to infinity, the sum from I equals 1 to n, f of xi, that's going to be I over n minus r squared over n squared. So we can write that I over n minus r squared over n squared. And then delta x, what was that? Delta x is 1 over n. Over here. Okay, so then that's going to be 1 over n. Okay, so now we just need to multiply this out, and then we can do the summation. So this is going to be the limit as n goes to infinity, the sum from I equals 1 to n. And if we multiply this out, we're going to get I over n squared. And then multiplying the second term, that's minus r squared over n cubed. Okay, so we just multiplied that delta x inside. Okay, just by the way, if you have any questions as I'm going through this, please just let me know. Okay, so I don't mind being interrupted while I'm going through this. Yeah, and also if I'm going too fast or too slow, please just let me know as well. Okay, so now we can separate this into two sums, just so that we have two smaller problems to deal with. So we can write this as the limit as n goes to infinity. The first sum, just note here, this n squared doesn't depend on r. So we can take that outside of the sum. So we can write this as 1 over n squared, and then the sum from I equals 1 to n of r. Okay, so it just makes it a bit simpler for us to work with. Same thing with the second term, this n cubed, that doesn't depend on r, so we can take that out of the sum as well. So we're left with minus 1 over n cubed, and then we have the sum from I equals 1 to n of r squared. Okay, so it's a bit simpler for us to work with. So now I just want to highlight these. This sum over here, so that's sum of r, and this sum over here. Okay, we know how to deal with those things. If we just take a look back at our summations here, we see we need to find the sum of r. So that's the second thing over here. And we need to find the sum of r squared. That's this third one over here. So what we can do is replace the summations with these new expressions on the right-hand side. So let's do that. So this first one we can replace. Let's replace the first one here. So that's going to be the limit as n goes to infinity, 1 over n squared. And then we replace the summation with n plus 1 over 2. And then the second summation we can also replace. The sum of r squared we can replace with n plus 1 to n plus 1 all over 6. So let's just highlight that here so we know what we replaced. So the blue summation in the top line we replaced with this over here. And the summation with r squared we replaced with this. Okay, so now we don't have to deal with any summations anymore. We can just do a bit of algebra and then take the limits. Okay, so that's done. Now, we need to try and simplify this as nicely as possible. So then we can take the limits. So what we can do is take the limit as n goes to infinity. So notice here, we've got an n in the numerator and an n squared in the denominator. Okay, what we can do is we can cancel this n with one of these n's. So we just have an n in the denominator there. So that's going to become 1 over 2n, n plus 1. Okay, so that just helps make that a bit nicer. And then we have minus. And then on this side, take a look, we've got an n in the numerator, and we've got n cubed in the denominator. So we can cancel this n, and then this won't be n cubed anymore, that will be n squared. Okay, so we're going to have 1 over 6n squared. And then if we multiply out these brackets, we're going to have n times 2n, that's going to be 2n squared. Then we're going to have plus 2n, and then plus n, so that's plus 3n. And then lastly, we're going to have plus 1. Okay, so that looks a lot better than the previous line. We've got a bit more work to do, and then we can then take the limit. So this is equal to limit as n goes to infinity. Over here, let's just take this into the bracket. So 1 over 2n times n, that's just going to be 1 over 2. 1 over 2n times 1, that's going to be 1 over 2n. Okay, and then the next bracket, we need to distribute that 3 times. So we're going to have minus 2n squared over 6n squared. The n squareds are going to cancel, so we're just left with 2 over 6. And then the next term, we're going to have minus 3 n over n squared. We're going to be left with an n at the bottom. So this is divided by 6n. And then we have minus 1 over 6n squared. Okay, so that's just distributing everything out. Okay, so now the last step is to take the limit as n goes to infinity. Now, the only terms that are affected are this term, and this term, because they have n in the denominator. So now just imagine, as n gets larger and larger, since it's in the denominator, this fraction is going to get smaller and smaller, okay, because the denominator is getting bigger. So in the limit, as n goes to infinity, the fraction is going to go to 0. Okay, so this is going to go to 0. This one's going to go to 0. And this one is going to go to 0. Okay, is there anyone not following that? Okay, awesome. Let's carry on. So this becomes the limit as n goes to infinity of 1/2. And then we can write this as minus 1/3. Okay, just reducing that fraction over there. Okay, so let's put this together. Okay, and then we've done the limit, so we can get rid of that there. Okay, so there's no more n's anymore, so the limit process is done. Okay, let's find a common denominator. So that's going to be 6. So we're going to have 3 minus 2 over 6. So that's going to be 1 over 6. Okay, and then that's our final answer. Let me try to zoom out here. You can see more here. Okay. Are there any questions about this? Okay, you can either unmute yourselves or you can type your message in the chat. Okay, any questions? Okay, cool. Let's take a look at another example then. Okay, so this is going to be example number 2. Okay, so very similar. So we want to find the area under f of x is equal to x squared plus 1 on the interval 1, 2. So from 1 up to 2. Okay, so before we get started with the calculation, we need to find those three things. Remember what they were. The first one is delta x. So that's going to be b minus a over n. So that's going to be 2 minus 1 over n. So that's going to be 1 over n. Okay, so that's done. The next thing that we need to find is xr. So that, remember, that's a plus r delta x. So here a is 1. So it's going to be 1 plus I over n. Okay, and then the last thing to find here is f of xr. So that's going to be, what did we have? We've got x squared plus 1. So it's going to be 1 plus I over n squared plus 1. Okay, so if we expand that out, we're going to get 1 plus 2i over n plus r squared over n squared, and then we still got that 1 over there. Okay, so we can write this as 2i over n plus r squared over n squared, and then 1 plus 1, that's just 2. Okay, so we've got everything we need to find the area now. So the area is equal to the limit as n goes to infinity, the sum from I equals 1 to n, f of xr delta x. Okay, that's the standard formula. You use that every time. Okay, so let's substitute what we know. So this is going to be the limit as n goes to infinity, the sum from I equals 1 to n, f of xr, we just calculated that. That's over there. So that's going to be 2i over n plus r squared over n squared plus 2. And then don't forget the delta x. What was that? That was 1 over n. So let's put that in. Okay, so now we can go through the whole process of expanding this out, doing the summations, and then taking the limits. So let's expand it out first. So this is going to be the limit as n goes to infinity, the sum from I equals 1 to n, 2i over n squared, because I'm multiplying the 1 over n inside, plus r squared over n cubed, plus 2 over n. Yeah, that's just multiplying that inside. Next, we can do the same thing that we did last time. We're going to separate this out into individual sums because that's a lot easier to work with. So let's do that. So this will be the limit as n goes to infinity of, now this 2 over n squared, we can factor that out because it doesn't depend on r. The n cubed, we can factor that out. And this whole 2 over n, we can factor that out as well. So this will become 2 over n squared, the sum from I equals 1 to n of r, plus 1 over n cubed, the sum from I equals 1 to n of r squared, plus 2 over n, the sum from I equals 1 to n of 1. Okay, so I just separated the summation out and factored out everything that doesn't depend on r. So now we've got 3 summations to deal with. Okay, the sum from I equals 1 to n of I, the sum from I equals 1 to n of r squared, and the sum from I equals 1 to n of 1. Okay, so we have to deal with these 3. So let's just go back to our page on summations. Okay, so the sum of r is going to be n plus 1 over 2. The sum of r squared is going to be n plus 1, 2n plus 1 over 6. And then that last one we needed was the sum of 1, and that's just going to be n. Okay, so we need these three to substitute. So let's do that. Okay, so this will be the limit as n goes to infinity, 2 over n squared. And then the sum of I we can replace with n plus 1 over 2 plus 1 over n cubed. The sum of r squared we can replace with n plus 1, 2n plus 1 all over 6. And then the sum of 1 we can replace with just n. So let's just highlight what we replaced. So the first summation we replaced with this. The second summation we replaced with this. All over 6. And then the third summation was just n. Okay, so all of the summations are gone. So we just need to clean this up a bit so it looks nicer. And then we can take the limit. And then once we take the limit, whatever is left over is our answer. Okay, so let's see what we can do. So first of all, with this first term, we've got a 2 in the numerator and a 2 in the denominator. So they can go away. Next, we've got an n in the numerator and an n squared in the denominator. So that can go and one of those can go. Okay, so we're left with the limit as n goes to infinity of n divided by n. That's going to be 1. And 1 divided by n, that's just 1 over n. Okay, so that's the first term taken care of. Now for the second term, we have an n in the numerator and an n cubed in the denominator. So that n can go, and then the n cubed will become an n squared. Okay, and then for the last term, we've got an n in the numerator and n in the denominator. They're going to cancel out. Okay, so the second term is going to become plus 1 over n squared, 1 over 6n squared. And then if we expand these brackets out, we're going to get 2n squared plus 2n plus n, so plus 3n, and then plus 1. And then right at the end, we just have plus 2. Okay, almost done with the cleaning up here. So let's just simplify that middle term, and then we're done with that. So we have the limit as n goes to infinity, 1 plus 1 over n plus 2n squared divided by 6n squared. That's just going to be 2 over 6, because the n squared and the n squared are going to cancel. 3n divided by 6n squared, that's going to be plus 3 over 6n. Okay, so one of the n's in the denominator will go away. And then if we're multiplying by 1, it's just going to be 1 over 6n squared. And don't forget that 2 at the end there. Okay, good. So that's much better. Now we just look at all of the terms that contain an n. So the second term has an n, the 3 over 6n, that's got an n, and the 1 over 6n squared, that's also got an n. Now, in all three cases, the n is at the bottom. So remember, as n gets very, very large, the fraction gets very, very small. So in the limit, as n goes to infinity, these three fractions are going to go to 0. So this one is going to go to 0. The next one's going to go to 0. And the third one's going to go to 0. Okay, so that's what happens when we take the limit. So what's left over? So we have a 1 plus 2 over 6, we can write that as 1 over 6, 1 over 3, and plus 2. Okay, so we've got 3 plus a third. We can get a common denominator of 3. So that's going to be 9 over 3 plus 1 over 3. So that's just going to give us 10 over 3. Yeah, and that's our final answer for the area. Okay, are there any questions about this one? Okay, so if you have any questions, just shout out or leave something in the chat. Just remember that point system that I was talking about last time. If you ask a question or answer a question, remember you get points for that. And then at the end of the semester, I'll see if I can turn those points into bonus marks. So I'm just dealing with the, I'll ask the module coordinator, maybe we can incorporate some bonus marks for these tests. Okay, and then we'll include this here. Another example. Yeah, sure. We've got another example here. Okay, so we've got another thing to do. Okay, let's look at another one. Let's look at something with x cubed. We haven't done that yet. Okay, we're running out of time, so it's going to have to be quick. So example number 3. Find the area under f of x is equal to 2x plus x cubed on the interval 0, 2. Okay, so again, we find these three things. So delta x is going to be 2 minus 0 over n. So that's 2 over n. xr, remember, is a plus r delta x. So here a is 0. So it's going to be 0 plus 2i over n. So that's just 2i over n. And lastly, f of xr is going to be, what was f of x? 2x plus x cubed. So that's going to be 2i over n plus 2i over n cubed. So we can simplify that to 4i over n plus 8r cubed over n cubed. Okay, so we got all the ingredients that we need. So now we can find the area. So the area is equal to the limit as n goes to infinity, the sum from I equals 1 to n, f of xr delta x. Okay, so we just substitute what we know. So that's the limit as n goes to infinity, the sum from I equals 1 to n. F of xr, we calculated that over here. That's 4i over n plus 8i over n cubed. And then delta x, that was the first thing we did. That was 2 over n. Okay, so first we multiply it out. So that's the limit as n goes to infinity. The sum from I equals 1 to n. 8i over n squared plus 16i over n to the 4. Oh, sorry, r cubed. Sorry about that. That's a cube. That's a cube. Okay, so now we can separate out the sums. So this will be the limit as n goes to infinity. 8 over n squared. Oh, sorry, that's an 8 over n squared. The sum from I equals 1 to n of r plus 16 over n to the 4. The sum from I equals 1 to n of I cubed. Okay, same thing as before, we replace the summations with those formulae. So this becomes the limit as n goes to infinity.
Sir,
Yeah,
sir,
yeah, what's up?
can you please slow down a little bit? You're too fast, yeah?
Oh, sorry, no, because the Zoom meeting only has 6 minutes left. So I just want to get through this quickly. We're going to run out of time. Okay, so we have 8 over n squared, and then the sum of r is going to be n plus 1 over 2, plus 16 over n to the 4, and then this is going to be n plus 1 over 2 squared. So we just replaced those summations with the formulae. Okay, so now we can simplify things a bit. So we've got 8 over 2. Let's just write that here. So that will be the limit as n goes to infinity. 8 over 2, that will be a 4. N divided by n squared, we're going to have an n at the bottom. So that cancels with one of those. And then we're left with n plus 1. Plus, we're going to have 16 over n to the 4, n squared, n plus 1 squared over 4. Okay, so the n squared and the n to the 4, we can get rid of that n squared, and then this becomes a 2. And then the 16 over 4, that's going to become 4. So this will be the limit as n goes to infinity. 4 over n times n, that's going to be 4, plus 4 over n, plus 16 over 4, that's going to be 4. So that's over n squared. And then n plus 1 squared, that's going to be n squared plus 2n plus 1. I got 4 minutes left. We should finish. So that's the limit as n goes to infinity. 4 plus 4 over n plus 4 over n squared times n squared. That's going to become a 4. And then we're going to have 8 over n. So 4 over n squared times 2n. Okay. And then 4 over n squared times 1. That's going to be plus 4 over n squared. Okay, so which terms contain an n? That's going to be the 4 over n, 8 over n, and 4 over n squared. Okay, so same reasoning as before. As the limit of n goes to infinity, the 4 over n is going to go to 0, because the denominator gets bigger and bigger. 8 over n, that's also going to go to 0. And 4 over n squared, that is also going to go to 0. Okay, so what are we left with? We've got 4 plus 4, so that's going to be 8. Okay, sorry for rushing this one. The Zoom meetings are limited to 40 minutes, so we're running a bit out of time here. Okay, but the lecture videos will be uploaded, so you can go back and watch it again if you need to. Okay, I just want to say one thing about the quiz that's coming up. So this Wednesday, we've got a tutorial quiz. So that's going to be on Moodle, the Learn 2022. You should see there's 4 quizzes with the dates. So the first one we're doing is the one on the 23rd. Okay, so the quiz will open at 10:30. So that's after our tutorial period. Okay, so the quiz will open and it will then close at midnight. So you've got from 10:30 to midnight to attempt the quiz. Now you're not going to have the full time to attempt the quiz. You're only going to have an hour. Okay, so it's open from 10:30 till midnight, but you only have an hour to do it. So once you've started it, you have to finish it within that hour. Okay. And then the topics for the quiz will be antiderivatives, which we did in the first lecture and the second one, and on Riemann integrals, which we've just done now. Okay. So if you do have any questions, please just let me know on WhatsApp or in the email, just let me know. Okay, but please don't forget the quiz on Wednesday. Okay, so that will count towards your final mark. Okay, it's very easy, it's just 10 marks. Okay, it shouldn't take you an hour to do it, but you have an hour anyway. Okay, so if you have any questions, please just let me know, and just look in maybe half an hour. The lecture video should be up on Learn 2022. Okay, I'll see all of you tomorrow. Bye, everyone.